Hi, welcome to Think Energy, a podcast that dives into the fast-changing world of energy through conversations with industry leaders, innovators, and people on the front lines of the energy transition. Join me, Trevor Freeman, as I explore the traditional, unconventional, and even up-and-coming facets of the energy industry. If you've got thoughts, feedback, or ideas for topics that we should cover, we'd love to hear from you. Please reach out to us at thinkenergy@hydroottawa.com. Hi, everyone. Welcome back. I'm pretty excited about today's topic because we're going to be tackling something a little bit technical, and that's always fun. Today is going to be the first of what might end up being a few different episodes looking at this term called grid modernization. So today we're going to do just a high-level overview, and then over the next few months, there'll be a couple different episodes that will dive deeper into some of the specific aspects of grid modernization. So that term grid modernization can be a little bit daunting, but that's okay. Our goal here is to pull apart these topics to better understand what they are and how they impact all of us. From those of us working in the energy sector all the way to the end users of our, product, if you will, our electricity customers. So let's start by a bit of a primer, and I think it'll be helpful to start by talking about what the grid is. So the electrical power grid has been called the world's largest machine and the greatest engineering achievement of the 20th century. And for good reason. Thinking of it as a machine is a great metaphor because just like a car or a sewing machine or a snowblower, there are a lot of parts. And if any one of those parts breaks or isn't working as it's supposed to be, that will impact the overall function of the machine. And the same is true for the grid. And the parts we're talking about here are the poles, the conductors or wires, the transformers, the switches, as well as the many different sensors and meters and communication devices that help the humans in the mix monitor and control things. The difference, though, is that, even for a complex machine like a car, there are hundreds or maybe even a couple thousand parts. But the electricity grid, even if we just look at, let's say, Hydro Ottawa's territory, there are hundreds of thousands of parts. And if we scale that up to Ontario's grid, we're talking about millions and millions of individual parts, all working together so that when you turn your lights on at home, electricity that was generated hundreds or thousands of kilometers away flows into your device and makes it work. It's pretty impressive. And if any one of those millions of parts breaks, there's an impact somewhere on the grid. If multiple things break or if there's something really critical that isn't working, that's a major problem. And we've seen these major problems. We've seen large scale outages. And, we tend to focus on Ontario's grid on this show because that's what we call home. But our grid is connected to our neighboring grids who are connected to their neighbors to form really an interconnected North American grid across Canada and the United States. It really is a modern engineering marvel. And, we didn't just get here by chance. This was kind of designed. Back at the early days of the 20th century, in the early 1900s, electrical pioneers met for the first time in what is now Kitchener, Ontario, to discuss what it would look like to wire Ontario's customers together to form a provincial electricity grid. Our predecessor company, the Ottawa Hydroelectric Commission, connected to that provincial grid in 1916. So what we know as the Ottawa grid in our service territory is over 100 years old today. Before that, across Ontario, reliable and continuous power in the region was kind of uncommon and really dependent on whether someone in the area, like a major business or a wealthy individual, had invested in a localized electricity grid for their own needs. An interconnected provincial grid was designed and implemented with the goal of making electricity available to all Ontarians, regardless of where they lived. And that kind of evolution of the grid in Ontario is similar to how it worked in other parts of North America and indeed the world. That's kind of how grids came about in the last century. Ontario's electricity grid, however, like all grids around the world, was really designed as a one-way street. So the idea was to generate and then transmit and then deliver that electricity to customers in that order. Back then, those pioneers really couldn't have imagined an electricity grid that would need to support two-way interactive things like small-scale distributed renewable energy, solar panels on roofs, or electric vehicles, or energy storage, and a whole host of other things that, want to do more than just draw power from the grid. As we've talked about, the ongoing energy transition and electrification, which are being driven by the pressures of climate change, is really driving a societal shift to bring the electricity system into the 21st century and to make sure it's powered with clean, renewable electricity. So our grid is starting to undergo this major transformation, and we won't be able to do that effectively or affordably by just using the same strategies and technologies and the same pace that we've been doing it at over the last 100 plus years. We need to take it to the next level. We need to rethink what we're doing to upgrade the grid and how we're doing it. And that's really what grid modernization is. It's not saying we don't have a modern grid, it's realizing that the grid of 10 years from now needs to be different in a much bigger way than it's different from how it was 10 years ago. That pace of change needs to happen quicker, and we need to bring on new functionality. It's not just, incremental change anymore. To help us make some sense of this, I'm really happy to have Jenna Gillis to chat with today. Jenna is the manager of distribution system integration at Hydro Ottawa and is leading this major project that we're calling at a high level grid modernization, or more specifically, our Advanced Distribution Management System, or ADMS. Jenna has been with Hydro Ottawa for 16 years and has held a number of different roles on the operations and system side of our business and really knows how our grid operates, how it's been operating, how the humans in the mix control things, and what's necessary to get us to that next stage that we've been talking about. Jenna, welcome to the show.
Great. Thanks, Trevor. I'm excited to talk to you about this today.
Yeah, I'm excited too. So let's start at kind of a high level here and help our listeners understand how we currently operate our grid today. So paint the picture for those of us who don't kind of get to see what happens behind the scenes. How do we control things today?
Yeah, for sure. So, what people might not realize that we actually have people sitting in a control room, centralized control room that looks at our system 24/7, 365. So, we've got people monitoring the system all the time. And they look at the grid state and they help direct field activities. They look at triaging outages as they become aware of them. And right now, we've got visibility to our control room to all of our substations. So, all of our, high level devices, but only down to about 8% of the feeders and not actually all the way out to our customer level. So, what does that mean? That means that we still rely on customers calling us or reporting online when they experience an outage. And all of that information does make its way back into our control room operators. And it goes into a system we call the outage management system, which helps us track and identify where we might be seeing issues out on the grid. So the operators then use that information to help make decisions in terms of controlling the grid, where they need to open and close devices, where they need to send field crews to restore power. So on top of that, most of these activities are done by field crews. So the system operators are in direct contact with our crews out in the field and providing direction on where to go and what devices to, have them physically open or close in the field. And we've got about 10% of our system right now that has remote capabilities. So that means that the operators can choose to open or close those devices basically at a click of a button back in the office sitting at a computer. So most of what we do today really is human based and does take an expert control operator to be monitoring these systems and making the decisions.
Yeah, so we've got this like really complex system, this, state of the art system, if you will, that requires, like you say, experts to keep track of what's happening, to identify problems and make decisions based on the information they're getting. I just want to pick apart a few things you said there. So when we're talking about our substations, just for our listeners, those are, spots in our grid where we take higher voltage and step it down via transformers to a lower voltage and then send that out on, wires. That's what we call our feeders to our end customers. We know what's happening at that substation level. We can see whether the power is flowing or not, whether switches are open or not. But once it gets past that, we lose some of that visibility. That's kind of what I'm hearing from you.
Yeah, exactly. And so that's why I'm saying like we still rely on those notifications from our customers to let us know where they're seeing the problems. And it comes into a system that we can look at in conjunction with that visibility that we have on the substations to help us understand what's going on.
Right. So obviously with such a, important and complex system, we're constantly improving and renewing and upgrading. That's not new. That's not something that we're just starting. But as I've kind of hinted at it in the opening there, we do need to change how we do things. So before we look into where we're going, how do we renew and upgrade today? What's our current process?
So we do have a robust asset management framework. So that's basically a program that tells us, and we look at all of our asset information, and that's whether that's poles, wires, transformers, switches, breakers, basically anything we have out on the distribution system. And we look at and prioritize where we need to invest and where we need to renew, replace, install, upgrade, all of that kind of stuff. So basically, as we do that right now, we go through and we'll incorporate new technologies like these remote controlled switches, like these sensors to bring information back into the control room to help us continue to evolve, meet our customer or system needs. So this process has worked really well in the past in terms of keeping pace with technology and the requirements of the grid and our customers. But right now we're seeing that we're falling behind. It's too slow to parallel installation of these new technological devices with these asset renewals or installations. So I mean, if you think about it, a pole out with wires on it can last over 50 years. We can't wait until we're replacing that 50 years from now to go in and add these new technological advancements. So what that means is now we're looking at a hybrid approach. So of course, we're going to continue to parallel activities where it makes sense with these asset renewals and upgrades and replacements. But we also need to strategically start placing these devices in an area that we're going to gain benefit from. And I'm talking about benefit from a control room operator perspective, benefit from a safety or field crew perspective, but also where we can provide value to our customers in terms of, expediting restoration efforts or, providing more flexibility into the system to allow more customer connections, whether that be, you know, new residential developments or whether that's, the next solar panel or battery or something like that.
Yeah, I went in for anybody who's familiar with kind of technological adoption curves and the pace of technological change. You talk about 50 years as the life of some of this equipment. The difference between technology and, let's say, 1930 and 1980 wasn't a huge jump when it comes to poles and wires and transformers. But today, the difference of 50 years is night and day. We're not talking at all about the same technology. So we can't wait for that whole cycle to go through before we're getting some of the tech in today that we need today in order to upgrade the system. So that's helpful to understand what that looks like. So let's look forward then. And when we talk about where we want to go with grid modernization, how we want to change that, talk us through what we're trying to accomplish.
Yeah, so I think I'm going to paint a little bit of a picture here in terms of how I think about grid modernization, because that's really helped me contextualize the way that we need to do things differently. So I think of grid modernization, that program in entirety, as like a stacked or a layer pyramid. At the bottom, you have field devices. So you have equipment that's remotely controlled or providing data in the field. So, we're talking about sensors or meters or switches, things like that. That's your foundation. On top of that, you then need a way to get that information back to systems, back to people. So then you need a communication infrastructure. So you need to be able to take that data and funnel it where it needs to go, which is the third layer. Data management, you need to store, organize, create access to that field data. And then finally, the fourth triangle right at the very top is your applications and analytics layer. So now you've got the data coming from the field, you're bringing it back and you're managing it. So now what are you going to do with that information? So these are the applications and analytics. So really the tools that digest that data and ultimately help make decisions. So that is what I envision kind of as the grid modernization pyramid. And you need each one of those layers to unlock the value from the layer below it. So you can't really have one without the other, all the way up to the top. So what we need to start doing is thinking about these layers in a programmatic fashion. What we've done historically is looked at the requirements on a project by project or program by program basis. So basically, you would unlock each one of those layers for that specific project or program requirements. What we need to start doing now is that grid modernization is going to be the foundation for everything that we do. So basically, every project, every program is going to require some level of information, data management, analytics, communication. So the way we're looking at that is this is now becoming a foundation to everything we do. So we need to be programmatic, roll this out so that regardless of what we're doing in the future, we have this foundation to rely on and we're not building it piece by piece as we work through project life cycles. So really what's different when I talk about grid modernization assets, and I'm talking about meters or sensors or remote control devices, is the integrated nature. So we talked about that pyramid. You can't use these devices without any one of those layers. Whereas you think of a traditional asset like a pole, you can, load it up on a truck and somebody can go and put it in the ground. So it's really the true convergence now we're seeing of what our technology, our IT systems, our operational technology, our OT systems, and then operations and asset management. So we really need to be looking at these things together as one and making sure we're all aligned to unlock each one of these layers.
Yeah, it really highlights the, I guess, cascading impacts of projects and decisions and bringing on new technology across the entire distribution business and how we do things and how we serve our customers. One is impacting the other in ways that hasn't really truly been the case before. So that's a great way of painting it. Thanks, Jenna. Um, let's talk about kind of the why behind this. What are the benefits that we're going to see by taking this approach, by taking this sort of accelerated upgrade process that we're doing? What are we going to gain from this?
So our overall grid modernization strategy is guided by five key objectives. So I'll go through each one of those and give you kind of a high level blurb on what it is that we're trying to achieve with grid modernization. So the first one is enhancing reliability. So the more monitoring devices you have in the field to understand the state of the grid, the more remote capabilities you have in order to operate and isolate and restore, the better reliability you have. The ultimate goal is moving towards an automated process where you have all of the foundation of the equipment, the communication channels, and the analytics to make decisions, and you can get outages restored much more quickly. The next one is what we call flexibility. So, adaptive grid flexibility. So, we want to make sure that the grid is dynamic to all of these changing energy demands that we're seeing come online. So, things like heat pumps or electric vehicles or solar generation or battery. We want to provide more options for the connections and be able to have the grid respond dynamically to these changing conditions. Next one we have is fortified resilience and robust security. So, resilience is really about the ability to withstand disruptions. And I'm talking about that from, a physical asset perspective, but maybe also a technology perspective as well. We want to make sure that we have a good diversity to be able to recover from disruptions. And we know there will always be disruptions, as we've seen kind of with the weather in the last little while. And then as we get more and more connected, we need to make sure we're safeguarding assets from cyber threats. Core to everything we do, we want to make sure that we're thinking about the customer. And so we're looking towards strengthening customer engagement and empowerment. So we've talked about, getting more data back from the field and being able to unlock new ways of doing things, new tools, and providing some of this information back to the customers to help them be better informed about their energy uses and their load profile and what they want to do with their equipment. And then finally, sustainable decarbonation and renewable energy integration. So we really want to look at reducing our carbon footprint by optimizing our planning and operations processes. So we talked about a little bit about automation. That will reduce our need to roll trucks for crews to physically go out in the field and operate devices. And basically everything above we talked about was, being able to incorporate renewable energy sources. We want to make sure that we have the ability to bring these resources online and leverage them.
Yeah, I mean, it really, again, not to kind of reiterate the same things we're talking about, but it's an all-encompassing type of project. Like everything we're trying to do, everything we talk about on this show, when it comes to the energy transition, whether that's having a more robust sustainable, smart grid on the utility side of things to enabling the kinds of things our customers want to do in terms of adding in more DERs, more self generation and storage. This project is kind of the foundation work that's going to support all of those efforts. And we're really only going to get so far without doing this kind of work, which stresses the importance of it.
Yeah, it really does unlock so much more by having this level of information and visibility into our system that we want to achieve.
Yeah, that's great. Okay, so let's kind of dive in here. You have this overall strategy that you and your team have outlined, which you're calling our grid modernization roadmap. Walk us through the main components of this and kind of the timelines that you've laid out. Is this a 6 months project? I say that kind of laughing, knowing it's not a 6 month project. How long is this going to take, and what are the major components of this?
So hopefully I've done some justification in terms of, mapping out how complex this actually is to deploy. And so our grid modernization roadmap is set out basically a set of initiatives over the next 10 plus years. So we've kind of, got a good handle on the objectives we want to unlock over the next 10 years. And so we've laid out what do we need to do to unlock those, and what's the timing of that. So we also need to understand that this is going to be dynamic and constantly evolving with, technology or market drivers. So, this roadmap is only as good as it is today until, something changes tomorrow. And we recognize that this is going to have to be dynamic and evolving. So, due to the complexity of it, we decided to basically bucket the program into 6 different component layers so that we can really get a sense of how one feeds into the next, as I kind of talked a little bit about the pyramid before. So the first one is physical infrastructure. Number two is sensing and measurement. The third is communication. Fourth is data management and analytics. Number five is control and optimization. And then finally, the last, number six, is business and regulatory. And so all of our initiatives fit underneath one of those 6 components.
Okay, so let's dive in and pull them apart then. I'd love to kind of talk more about each of those. And just for our listeners, we're going to keep this fairly high level. Just we don't have time to get into super detail on all 6, but the plan is actually to take future episodes and maybe pull apart some of these in more detail. So if you're super interested in what we're talking about today, don't worry, we'll dive into more detail. So let's start at the top with physical infrastructure. What does that entail?
So the physical infrastructure component really targets the challenges and opportunities posed by electric vehicles, electrification, climate vulnerability on the grid itself. So we talked a little bit about the fact that we need to start adapting or continue to adapt our asset management practices to address these factors. So, what does that mean? That's things like I talked about before about increasing the rate that we add new technology or remote switches and sensors and things like that into the system. And I talked before about resiliency and flexibility, and a part of this is incorporating an increased level of climate risk consideration into our asset assessments and our plan for renewal or replacement of those devices.
Yeah, so this part of the strategy is really about, the actual devices in the field that are going to be installed, the new technology that we want to get out into the field on our grid. Let's pick apart that last piece a little bit, the climate vulnerability. Um, how are we also trying to, for lack of a better word, harden our grid or make it a little more resilient to some of the weather events we're seeing?
Yeah, so I think everybody is probably well aware that it's not about if we're going to see another large weather event. It's about when. We've always incorporated those types of things into our asset planning, but now the frequency and severity of these things is becoming higher and higher. So what we started looking at is, reliability has always been a priority, but now we're shifting gears a little bit to resilience. So I talked about that before, and that's more about withstanding and recovering quickly from these events. Like I said, we know they're going to happen. So how are we going to make sure that we can recover as quickly as possible? So with looking at that, we're looking at things like reviewing our design elements, like strengthening the poles that we install, or doing strategic undergrounding in sections of overhead lines that we know have a high exposure and like subsequent consequence of failure. So we are building all of these strategies now as well into that asset management in the deployment of what we're putting out into the field.
Great. And again, just for our listeners, I want to talk more about what we're doing and what can be done on that climate resiliency piece. So keep your eyes open for a further episode on that down the road. Okay, so the next piece you talked about is sensing and measurement. At a high level, talk us through what that means and how that contributes to overall grid effectiveness.
Yeah, so sensing and measurement is more than just installing the physical devices that we kind of talked about in the previous component. And it's devices like sensors to detect faults and report back on where there might be disturbances or outages on the system. And it's more than just meters on customer homes. It's about integrating that data back into our grid management systems. So, our ultimate goal is to have real time access to all of the data from our customer meters. That's over 350,000 meters. But to achieve this, we need to have a robust strategy to transfer that information, store that information at the right frequency, meaning in terms of, how often do we get the information from these devices and how often do we receive that information back in the office for all of the different use cases. And there's hundreds of use cases for that information. So this does represent a significant shift in the way that we're using our meters right now. Right now, when I talk about our customer meters, we take a reading from those once every 24 hours with hourly level of granular data. So it's basically once every 24 hours, we get 24 points of data. And we're talking about what we want to do with grid modernization. We're looking at, reading those meters, once a minute with more information. So you can see there is a huge shift in the way that we've got kind of the infrastructure set up around those things.
Yeah, when you talk about those numbers, so 24 data points every day, changing to potentially reading every minute. Remember, we're multiplying that by 350,000. So that's a huge amount of data. And you know, Jen and I are working for Hydro Ottawa here, one of the sort of medium-sized utilities in the province of Ontario. We've got other utilities in the sector that have millions of customers. So the importance of data and how we handle that, and we'll talk a little bit more about that in a minute, is certainly pretty high on the priority list. Some of what you mentioned there sounds a lot like what we call advanced metering infrastructure 2.0 or AMI 2.0. So for those kind of in the industry that know what that is, that's maybe the next generation of meters we might be talking about. How does that differ from the existing smart meters that exist all across Ontario? And that doesn't mean they exist everywhere in North America, but at least in Ontario, we've got kind of what we call AMI 1.0. What does AMI 2.0 look like, and how does that change things?
Yeah, so there's kind of one key critical factor. AMI 1.0 was rolled out with, one main purpose, and that's billing. And so our meters are set and our communication infrastructure is set up to, again, report back on a frequency that makes sense for monthly billing. So, like I said, in other words, that's a once a day reading. And so that data is stored and available the next day. So not what we would call real time. So this information is incredibly valuable, and we do use it for planning and supporting operational processes, but it doesn't allow us to respond real time to the conditions on the system right down to that customer level. So AMI 2.0, which is basically the next step from that first level of having meters that we can read remotely from the office, is more just about then, like as I mentioned before, about installing sensors. It's not just changing those meters. We talked about the data requirement. And so it's also a substantial upgrade to our communication infrastructure to get that higher volume of data back from the field. And what are we going to use that information for? Like, why is it important to have it real time as opposed to, the next day? It's because these meters will be able to give us things like a power off notification. So we talked before about the fact that we do still rely right now on our customers calling in to let us know that they are out of power. In the future with AMI 2.0, the intention will be that these meters will report right back into that outage management system, and we will know as soon as that meter sends a signal to say, oh, I've lost power. The second piece of that is we want to know when your power comes back on. So we're going through, we're doing our restoration efforts. We want to make sure that we're picking everybody up. So we'd also be able to get a signal coming back on and say like, yep, I just turned back on. So having this visibility right down to the customer level gives us so much more flexibility in terms of how we can respond to the system in real time. The other one, it also opens a whole bunch of other future use cases, such as, we talked about unlocking benefits for our customers as well, about real-time data, about their energy uses, and, providing additional tools or software to help them look at their consumption and overall save money on their bill. So, I mean, that's a future step. We're not there today, but the work is on the way to achieve that. And that, those are some of our guiding principles around what we're doing for grid modernization.
Yeah, it really highlights how powerful it can be to know what's happening in real time at every, end use of our entire grid, every customer knowing exactly where the issues are, exactly when they get resolved or don't get resolved. So that's pretty powerful information. So, as we've kind of talked about, there's a natural tie over from having that sensing and metering equipment out in the field, gathering that data, and then getting that data back to our system office where we can use it. And that's where communication comes in. So, tell us about the critical role that our communication technology will play.
So today, Hydro Ottawa has a communication network that which spans our entire service territory, and it uses a bunch of different technologies or different channels like cellular networks, radio, fiber, phone lines. So we've got a diverse communication network that sees across our service territory. So again, kind of paralleling the way that we've been deploying some of these smart technologies, this strategy is very effective in accommodating the sensing and measurement control devices that we've been doing to date. But again, we are talking about an increase in data, we're talking about an increase of physical devices, means that we need faster, higher capacity methods to get that data from the field back into our systems. So again, this is all part of the strategy that we're focused on, is making sure that we have this backbone communication infrastructure ready to connect these devices into. We don't have all the answers on that yet, but we know roughly where we need to get to. And again, it's part of this roadmap to make sure that we achieve those objectives.
So, when we talk about communication and sending data over communication networks, increasingly, we all know the challenges with cybersecurity, and people may be wondering, how are we going to protect all this data that's now flowing, that's giving real time information about, power use on our grid? How does cybersecurity fit in within this plan?
So we do have a robust cybersecurity standards that we follow, and a dedicated team who looks after these things for us. So as we know, as the grid becomes more and more connected, cybersecurity becomes an even more crucial part of this, and it's a critical factor. And we mentioned it as one of the core objectives of the program is to, maintain our security. So if you think about it in the past, when we went and just installed a device that somebody could go and control from a bucket truck, you didn't have to incorporate cybersecurity standards. You didn't have to have a device go through the multiple levels of checks and validation that we have to do things today. So it is another shift in the way that we operate, right? Is that, and again, we need to keep pace on the technology standpoint of things, not just the physical device.
Mhm, totally. Okay, so there's definitely a bit of a flow here because we talk about the data in the field, we talk about communication. Now we've got that data coming into Hydro Ottawa, into our system office. We kind of move into that next piece you talked about, data management and analytics. How does all this data help us transform our grid? What do we do with this data once we get it?
Yeah, so raw data coming from the field isn't overly valuable. What you need to do is you need to have an established framework for that information to allow the users to access that in real time. And so when I'm talking users right now, I'm talking about, it could be a number of different meanings, but today we're really talking about our Hydro Ottawa control room operators. I'm talking about, our planning teams, our operations teams, and our maintenance systems information. So you need to make sure that you have a framework to access that information in meaningful formats. So, eventually, once we get a sense of what this information is and we have a robust strategy around it, we could be providing that information to customers for their energy management systems and use cases like we talked about before. So, the other piece is as we collect more and more information on the condition and use of our assets, we can refine and enhance our decision making, planning, operations, asset management becomes more and more informed. So, each one of these pieces of data is critical, but you need to make sure that you have a strong framework around it. So you are gleaning the value from that information.
Yeah, I mean, you're kind of talking about analytics here, and analytics is essentially combing through that vast amount of raw data and pulling out insights to make smart, evidence-based decisions. I know I'm asking you to kind of look in a crystal ball here, but what kinds of insights are you expecting to get once we have access to all this data?
Yeah, so really the expectation is the more information we have about how the grid operates and performs under a variety of different conditions, we'll be better able to plan and optimize that configuration. And I talked before about, that grid resiliency. So what is the best configuration of our network? Where do we have problems downstream that we maybe didn't see before, but now we see, so we can start setting things up differently. It'll help us enhance an ability to appropriately size and prioritize our investments and make better use of the existing assets that we have. So, in light of all of these uncertainties we got about electric vehicles, electrification, and climate risks, the more information we have at our fingertips, the quicker we're going to be able to respond and adjust our strategies to keep up with those market drivers.
Yeah, asset utilization is a really fascinating piece. And again, this isn't the episode to dive into that, but just quickly for our listeners, you may be familiar that utility companies have to design to peak load. So we need to be able to provide the highest amount of power that people need, whether it's a hot, sunny summer afternoon and everyone's got their air conditioning on. But when we're not using that peak load, assets are sitting underutilized. We're not using the capacity we need. And the more of that capacity we can use, the better. And by putting in some of this technology, by gaining those insights, if we can do appropriate switching or better planning to utilize our assets better, everybody wins. Our grid is more effective, it's more economical, and I think we're all in better shape. So great to see where we're going with that. The next component you talked about is control and optimization. So we talked about how we control the grid today and how it's kind of a manual process. We have, really smart folks sitting in our system office who are making important decisions. How does that control evolve with this strategy?
Yeah, so this layer, this control and optimization is really about using all of that data to make informed decisions. So we're actually undergoing one big transformative project right now, and you referenced it earlier. It's our Advanced Distribution Management System, or ADMS. So what this is it's really a complete modernization of the software tools used by our control room operators. So the individuals sitting at the desk watching the state of the grid 24/7, 365. So to give you a sense of what they're using today to see that picture is our operators have to interact with at least 5 separate systems right now that are not integrated to gain all like that full picture. So the intent of this project and the main driver is to paint one pane of glass for the operators. It's amalgamating those 5 separate systems into one view to give them better insights into the state of the system. So we're going to be amalgamating these 5 systems, but also then incorporating more of this field data that we've talked about collecting as well. So some of the things that we can unlock with the advanced distribution management system that we aren't capable of doing today is working towards implementing a fault location isolation and service restoration scheme. So if you're in the industry, that's well known as FLIZR. So what this is
A fantastic name, by the way.
yeah, what this is really about is two-way communication to and from these field devices and sensors to get a sense of where we might be seeing issues on the distribution system. So where we have faults or where we have outages occurring. The system will then, it's an analytic platform that takes all the information back and it can propose to the operators switching to restore as many customers as we can and isolate that faulted section of line. This future step of that is once we've get comfortable and we know the system and the analytics are working effectively, is to allow the system to do it automatically. So instead of proposing switching to an operator who can make the decision and then perform the switching or roll a field crew, eventually we'd be able to do this automatically. So once the system is configured and we've got all of those remotely operable devices in the field, we would allow the system to make automatic decisions and restore and isolate the faulted sections to line.
So, I mean, you're talking about analyzing data and making decisions automatically. It kind of sounds like AI a little bit, which of course is a pretty, buzzword these days in a lot of different sectors. Does AI come into play here in terms of making decisions and controlling things on the grid?
Yeah, so I mean, we have a number of use cases that we're looking at right now with AI, and obviously, the more data we get, the more opportunities we have to leverage technology and AI. So some of the things we're looking at right now is things like predicting and forecasting demand levels or load levels out on the distribution grid based on a number of inputs. So like the grid status, what's the weather going to be? What was the historical loading, things like that. And when you have multiple factors like that that feed into, what is your customer's load going to be, you need something like AI to be able to digest all of that information and come up with recommendations. Another one is just analyzing multiple sensors and control points to help us predict failures. So the more information we're getting back on the assets, we can use AI to help us explore or build models to help us identify exceptions in those large amounts of data, and in order to be able to flag potential failures and allow us to intervene and course correct before they potentially cause an outage or something like that.
Yeah, so that would be, and correct me if I'm wrong here and interpreting this wrong. That's like taking a bunch of data points on how our existing equipment is running, maybe, the temperature that we're seeing or the loading on that equipment and how that relates to its normal operating load, and being able to say, we think based on the operating conditions, this piece of equipment is likely to fail faster than otherwise it would. Is that kind of what you're talking about?
Yeah, exactly. Or even in real time, this piece of equipment is going to overload. And so you need to take intervention and move load around or something like that as well. Yeah.
Yeah, and all of that data, I mean, that's all things that we know how to do, but no human can possibly do that in real time with the amount of data coming in. And so that's where some of this advanced technology and AI, artificial intelligence, really comes into play to help us pull that out of the massive sea of data that we're going to be getting in.
Yeah, exactly.
Okay. Okay, so the last component you mentioned, on the surface, it might seem like a bit of an outlier, business and regulatory, but I think it really ties it all together, and it's again one of those foundational pieces. So, the electricity sector is highly regulated, as our listeners probably know. It's extremely complex to navigate. It has been accused in the past of not being very conducive to innovation and change. What are some of the priority areas that you've identified, whether that's, dialogue with our regulator, the Ontario Energy Board, or just, regulations and policies, internal or external to our organization that you think need to come into play to make this modernization happen?
Yeah, the whole objective of kind of the business and regulatory, stream through good modernization is about building a holistic approach to build operational structures and processes to be able to address and respond to these dynamic market drivers. So, one of our big priorities right now is to raise awareness of this approach, and the fact that we were broadening our investment categories beyond what I'd consider to be those traditional asset condition or reliability or end of life types of drivers to now include and layer into it these system observability, these control points, and this resiliency, which is a shift in terms of how we've justified or how our regulator has looked at the way that we do business in the past. But we also make sure we need to look internally. So it's not just about looking externally and making sure that we're aligned with our regulator, but it's about looking at our internal business process to make sure that we're aligned to deliver the value that we've set out for the grid modernization objectives. So we need to make sure that we have mechanisms to be able to measure our success and feed that back into a continuous improvement. I talked about the roadmap is needing to be a dynamic. So we need to make sure that we're monitoring our progress towards the delivering of those objectives and have ability to stop and pivot where we need to, when we need to.
Does this kind of open the door for new business models or new way of doing things? And are there like specific pilots that we're considering or specific initiatives?
Yeah, there's a lot going on in the electricity sector right now. One of the big kind of hot topics right now is that there's indications that local distribution companies may need to in the future operate at a similar capacity to the way the independent electricity system operator behaves. So the IESO they control and dispatch the bulk system. So they look at they do forecasting on the Ontario energy needs, and they throttle on and off generation and those types of things. The thought is this is going to be needed at the local level. So if you look at Hydro Ottawa service territory level, we may need to look at dispatching generation and doing dynamic load management and things like that. And this is a holistic change to the way that we operate right now. And so we need to be able to future proof ourselves to move down that path if that's where things go. And dispatching energy resources, I said it kind of as, it's one thing, but we talked about a little bit of a comprehensive analysis system to take in all of those inputs and understand forecasting and where things are going to be, including economic factors and all the different customer types, including the widespread adoption of electric vehicles or battery storage. So it can get to be quite a complex system.
Yeah, and it kind of sounds here like you're talking about the distribution system operator model or DSO. And again, like I've said a couple times, I think there's a future conversation or future episode about that. But it's like you say, having the distributors, the local distribution companies, able to make decisions on how energy is used within our grid, and then that feeds up into how ISO is running the kind of broader provincial grid. So I'll put a pin in that one, and we'll come back to that on a future episode.
Yeah, and so something that's important for us to understand too is if we do go down the road of a DSO, we need to know where and what could impact our operations, or where we could have those triggers or throttles on the distribution system. So right now we're undertaking a pilot program as well, looking at EV charging, and we've called it EV Everywhere. And I'm sure everybody's well aware that EVs are, could be a huge dynamic load that show up on our system anywhere at any time, whenever somebody wants to plug in their vehicle. And there's also talk about using EV batteries as an energy source to feed back into the system to help grid capacity constraints. While that still might be a long way off, there are still solutions that we want to manage to leverage the chargers. And we look at, instead of having everybody come in and come home after work, plug in their EV and start charging at 5 p.m. and causing, a new peak in our demand, looking to be able to stagger that charging, and whether that's stagger at a local, community level, whether that's needing to stagger at, we talked about a substation level, or whether we need to stagger that at a whole Hydro Ottawa service territory capacity. So EV Everywhere is really looking at the use of artificial intelligence to help us make those predictions about where and when and how long EV charging needs are required, and being able to manage those devices so that it reduces the impact on our distribution network. And we talked about increase our asset utilization. And we're hoping to be able to push that beyond just the pilot stage that we're in today.
Yeah, and really, that's for the end user, for our customers, that's going to help us remove barriers to you getting that EV and being able to charge at home or where you live or where you work, so that we're not having to modify the grid drastically in order to allow that. We want to make that process as easy as possible, and this is testing out a strategy to do that. So, Jenna, that's super fantastic to hear about this roadmap that you have. And I mean, look, the listeners out there who know me know that I'm pretty optimistic and I'm pretty excited about this stuff. But I think it's important to highlight some of the risks. So it's a great roadmap, it's a great plan. What could trip us up? What could get in the way of us being able to implement the strategy and rolling it out as you envisioned it?
I think the first one is that this is large. This is transformative. This touches multiple business areas, and is driven by multiple outside influences. So we need to make sure that we've got holistic change management strategies. We need to look at the pace of change that we're implementing, and not necessarily on the distribution grid, but also on our systems, our process, our people. So we need time to make sure that when we introduce a large change, that we have some settle in, we have some time to adjust and correct, and keep that dynamic, continuous improvement process as we move from one, and it's going to be move from one change to the next at a pretty rapid pace over the next few years. And with all that change, we need to have the right people. We need the right people, we need the right skill set. And some of these skills are things that we haven't done before. So these are new responsibilities, new skill sets to the organization. And I'm going to put a little plug in here, is that we're hiring right now. So take a look at our careers page. If I've painted an exciting picture and you want to be a part of this, take a look. We're hiring some of those skill sets today. And this stuff is going to span multiple years, right? So I feel like in the past we kind of had, like, oh well, that's a 5-year program, and then you're done. No, like this is going to be a continuous evolution, and these can span multi-years. And I talked about it before. We need to be able to adapt and pivot to meet the requirements of technology and our customers, and we need to expect that. And so we need to build that ability to stay dynamic through these multi-year programs, to make sure that, we maybe we need to change what our grid modernization objectives are halfway through, and that's okay. We can do that.
Yeah, I think if there's one kind of common theme that comes up in these conversations that I get to have as part of the show is this is big change that we're talking about here. This is sort of fundamental change within not just one organization, within an entire sector. And we're all trying to figure out how we do it. We've all got different ideas and we're working together. And I think your point about we need the right people to do that. We need people that are really passionate about this and really smart and see the opportunity to create that change and realize, hey, the utility is not a bad spot to do that. It's kind of at the epicenter of a lot of what we're doing here when it comes to energy. So great thoughts. So, I mean, that's kind of the end of the grid modernization question. So I don't know if now we get into the easier part of the conversation or the harder part. But we
You're talking to an engineer, so when we talk personal, it's harder than the technology.
Awesome. Yeah, I can definitely relate. So I mean, we always end our show with the same questions to our guests. And it just kind of helps us learn a little bit more about you. So as long as you're okay with it, we're gonna dive right in.
Yeah, let's do it.
So what's a book that you've read that you think everybody should read?
So, I mean, I think I kind of already touched on it and the fact that these were the more uncomfortable questions for me. One book that I read that I really enjoyed is Quiet, The Power of Introverts in a World That Can't Stop Talking by Susan Cain. She has a TED Talk too. So if you want to kind of get a short snippet of what she's talking about, but really it's about dynamics of how our world emphasizes extroversion and basically everything that we set up and everything we do. And so we need to make sure that we're allowing space for our introverts.
Great. I like that. What about a movie or a show?
So I'm not a big movie person, but I've got a TV show. It's pretty niche. It's called The Curse of Oak Island. I'm sure probably not very many people know what I'm talking about, but I followed this story from the beginning. So once this show started airing a long time ago, it's basically about a 200-year-old treasure hunting mystery in Nova Scotia, and it touches on archaeology and some potential connections right back to the Knights Templar. So I've become pretty invested in this one show.
Is your next vacation to Halifax to go and check out the Oak Island and find this treasure?
I think it would be pretty cool maybe once like to go and see what they're doing and like the size and scale of what they're doing. But yeah, I wouldn't necessarily dedicate a whole trip to it.
Okay, good to know. Well, maybe on that note, if somebody offered you a free round trip flight anywhere in the world, where would you go?
Yeah, so not Nova Scotia. I'd love to be able to be out and see the Northern Lights. So somewhere like Iceland or Greenland. I think seeing something totally different than what I'm used to here in Ottawa.
Very cool. Who is someone that you admire?
So I feel like this is going to be really cliche, given that Taylor Swift has recently released another album. But Taylor Swift, I think she's an incredibly powerful and positive female influence, and I think she's a great role model. She's got strong, big business strategy and authenticity. So I think she's a great role model for girls to be looking up to.
Yeah, I'm currently I'm not ashamed to admit I'm currently going through her Eras tour with my kids right now. We're watching it in kind of little bits and pieces here, and while we're watching, I'm texting my nieces because they're big Swifties. So that's a great example. And finally, and you're a great person to answer this question, being kind of right down in the weeds of the energy change. What is something about the energy sector or its future that you're really excited about?
It's really about the pace of change. So we talked about like I've been with Hydro Ottawa for about 16 years now, and I feel like we've always been saying it's coming, it's right on the horizon, right? So it's here. We're seeing it. We've always been kind of forecasting and wondering when it was going to hit, and it's here. So I love that we need to be innovative. I love that we need to rethink the way that we are doing things, and I'm super excited to start breaking down silos and building these cohesive strategies and working together to problem solve because it's more important now than ever to build that integration with, everybody on the team. So that's what I'm super excited about.
Yeah, I can definitely relate to that. That's what keeps me coming into work every day too. I really like that. Jenna, this has been a really great conversation. Thanks for sharing your insights with us on what Hydro Ottawa is doing when it comes to grid modernization and just kind of sharing your experience and your expertise on how we're changing and getting ready for the future. I really appreciate it.
Oh, thanks, Trevor. Hopefully I did some justice to what we're doing, and hopefully I've piqued some interest in diving deeper into some of these very specific initiatives that we've got underway.
Absolutely. And don't be surprised if I reach back out to you to come and dive deeper on some of those as well. So we'll have you back on another time.
Perfect. Thanks a lot, Trevor. Appreciate it.
All right, thanks. Take care. Thanks for tuning in to another episode of the Think Energy podcast. Don't forget to subscribe wherever you listen to podcasts, and it would be great if you could leave us a review. It really helps to spread the word. As always, we would love to hear from you, whether it's feedback, comments, or an idea for a show or a guest. You can always reach us at thinkenergy@hydroottawa.com.